Alright, we're recording. Alright, Surgite, careful with the iPad. And let us pray. In nomine Patris et Filii et Spiritus Sancti. Amen. Sancta Michael Arcangelo, defende nos in fede, contra nequitia et insidias diaboli, est presidio. Impere illi Deus, supplices te precam, tuque princeps militiae celestis, Satanam, aliosque spiritus malignos, qui ad perditionem animarum pervegantur in mundo, divina virtute in infernum detrube. Amen. In nomine Patris et Filii et Spiritus Sancti. Amen. Please have out your homework. 1F is in Franklin.
Oh, Mr. Cont'd, I have a bunch of
Okay. So 1F.
What? Did you do it?
We did. Okay, so.
So this is like, do you just want me to give you?
Get it by Monday, otherwise it'll tank.
Sorry, this is like all the assignments.
All right.
Because I'm working on
Oh, I see it is labeled. Oh,
Yeah.
thank you. That helps a lot.
I know I asked, what are the
B,
B's?
D,
You're not gonna be
C. Yeah, 1F. Okay.
Yeah, sorry, it was like.
No worries. Yeah, keep looking for 1F. I'll be right back.
You're texting. Yeah, okay. I'm asking you what the phone is.
Just figure it out. Guys. Well, did we go through the answers on your charger? Oh, no, we did not. I think did we cover the topic? Yeah. Did we go through the answers? No. So you're not bad. No one uses it. I can't be charged USB.
Charging this phone 5 MPH. I looked at the screen like Michael Jackson. You just said Jack on your calculator.
Oh, no. I'm sorry. Dang it. That's not what I wanted.
Alright, did you find it? Are you stored?
No, I don't.
Okay. Bring it on Monday.
I will bring it on.
Alright. We're looking at one, we did not go through 1E yet as far as the answers go. So if you could travel back in time, metaphorically speaking, to 1E as an Egbert, we're going to go through those. This is the worst one.
Okay, I'm gonna move
Don't forget about that. Oh,
Thank God.
1E and 1F. That's exactly what I'm talking about. I scored it. Actually, I scored everybody's run. I just went around now. What's going on now? All right, space front, please.
Wait, did you
Ham.
Mr. Cont'd.
Need to get something out first. We're going through the answers on 1E. Let me ask you a quick question. Did I, now that you bring it up, did I put scores on everybody's 1E or no? A bunch of people nodding. Yeah, so just if people were gone, I may not have, but I'm assuming unless you tell me otherwise, that everybody has scores on their 1E right now and their 1F, unless you have arrangements otherwise. Okay? I'm about to read off the answers for 1E as an expert. Let's see what we've got here. That is page 25, 29, thereabouts-ish. Here we go. We're doing 1 through 31 odd. Number 1. The answer is 7I. Number 3. The answer is -3. I'm surprised by that. Number 5. The answer is +2. Number 7. -2 plus 5I. Number 9. 8 plus 32I. Number 11 is 37. Number 13 is 30. Number 15, 31 plus -34I. Number 17, -9 plus -40I. And it repeats up to number 17. Okay. Number 19, we're starting to get fractions. It's 2 over 29 plus -5 over 29 times I. Look at that. Number 21, 12 over 13 plus 5 over 13 I.
For that one, I put 5I over 13.
Oh, 5I over 13, I know what you mean, but I would like the I off to the side. So it goes, that'll make the form A plus BI. Number 23, it's kind of a mess. 19 over 51 plus 10 radical 2 over 51 times I. And it repeats up to number 23. Right, number 25, -5I. Number 27, the answer is I. 29, the answer is I. And 31, the answer is I. The answer is B. All right. So, questions? Is it bad word? Oh no, it would be good grammar. It is I. Any repeats? Yeah. 19 repeat? 19 was 2 over 29 plus -5 over 29I. Any other repeats? All right, let's take a few minutes. Questions? Any of those you want to see dissected? Good, please. Okay. 19. So 1 over 2, sorry. 1 over 2 plus 5I. This is what we affectionately call a hostage situation. The way we get rid of a compound thing like a complex number, you multiply by the what? What's the special word? Yes. Conjugate. What is the conjugate of 2 plus 5I, Franco? 2 minus 5I. Multiply by that on top and bottom. I'm going to kind of turbo speed this because we got a lot to cover. We're going to distribute the 1, which is totally unexciting. 2 plus -5I. The bottom foils. Just out of curiosity, does anybody recognize the pattern in the bottom? It's a pattern of factoring. Yes? That's the difference of 2 squares. When you're done, you should have something squared minus something squared. As it turns out, you're going to have 4 minus 25I squared. If you foiled it, you would get that after you cancel the inner and outer. Oh, math people. Oh, Nate. What is I squared? -1. So what is -25 times -1? positive 25. What's the new bottom? Say again? 29. So it's 2 plus negative 5I over 29. There's one more step I'd like you to do. Abby, what would you do?
You split it.
Exactly. What's the first fraction?
2 over 29.
2 over 29.
Plus 0 side of it.
Correct. Times
I.
I. And that's it. Make sense? Next. Any other stuff?
2 over 23.
20 what?
23.
23. Yes. 3 plus I radical 2, 7 minus I radical 2. Now this looks a little frightening because there's an I on the top as well as the bottom. You do it the exact same way. You multiply top and bottom by the conjugate of the bottom. 7 plus I radical 2. I'm just going to FOIL this because I want you to see all the gory details. FOIL, so it's 3 times 7 is 21. The outer is 3I radical 2. You can also write it as 3 radical 2 parentheses I. That doesn't really matter. Plus 7I radical 2 plus I squared radical 4. Let me see where I got that. First shot around the last. So I times I is I squared, radical 2 times radical 2 is radical 4. That simplifies, but we'll do that in a second. On the bottom, it's going to be 49 minus I squared radical 4. I did difference to do squares. Feel free to FOIL it. You'll get the exact same answer. Help me out, Sam. Radical 4 is what? What's I squared? So what is that? This becomes negative 2. And this is negative 1 times 2 times negative. So what is that? Sam? Negative times negative is positive 2. What's the new bottom? Which is 51. Good save. On top, we have like terms here and like terms here. I'm going to do the real parts first. 19. 3I radical 2 plus 7I radical 2 is 10I radical 2. So here's what I do. I want to plop the I on the end. So it's 19 over 51 plus 10 radical 2 over 51 times I. Does that make sense? Any others? Yeah.
31.
31. Look at that. The I to the negative 35th? Yeah. 31, I can do that up here. Actually, I'll do it here because I want to make sure it's on screen for the camera. I to the negative 35th. If you remember, negative powers don't get into the basement. This is 1 over I to the 35th. Now what you do, remember, what's I to the 4th power? Nick? 1. What's I to the 8th power? 1. What's I to the 32nd power? 1. Exactly. I want to split off as nice of a multiple of 4 as I can and have the leftovers behind. The reason I like multiples of 4 powers is that turns into 1. Does anyone remember what I to the 3rd is? Mary, what's I to the 3rd power? What's I to the 1st power? I. What's I squared? Close. Negative 1. I squared is negative 1. So if you need to piece it together, this is really I squared combined with I multiplied. I squared is negative 1, and I to the 1st is I. So what's the final answer? Negative 1I. Or just negative 5. That's I to the 3rd power. So we're looking at 1 over negative 1I. We're almost done, except there's a radical in the basement still. I'm going to multiply top and bottom by the radical. It becomes 1I over negative 1I squared. So, Josh, help me out. What's negative 1I squared? Well, what's I squared? So what's the bottom? 1i over 1, which is better known as I. And that's your answer. Questions on that? Next. The others, yeah. I'm sorry? Number 3? Oh yeah, radical 1 times radical 9. Did anybody get positive 3 on this one? Yeah, so did I the first time I did this problem. I remember it back in, whenever it was, in second year algebra. It was, I didn't mean to erase that, darn it. People watching at home, just hit rewind. So yeah, radical -1 times radical 9. -9. It certainly seems we think a radical times a radical is a radical. So just multiply these to get radical 9, which is 3. Why are they saying -3? Well, what's the order of operations? Who thinks they remember it precisely? Yeah. PEMDAS. So what comes first? Parentheses, then exponents, then what? Multiplication and division from left to right. So multiply and divide are pretty much the same thing. And then addition, subtraction. Question, what comes first? Multiplication or exponents? Exponents. Where do square roots fit in the order of operations?
They're exponents, right?
They're exponents. So guess what you do first? Yeah, when you multiply these together, you're actually violating the order of operations, which is way back when. Here's what you do. What's radical -1? Does that mean what radical -9 is? No.
Is it just 9?
Yeah, sort of. It's radical 9 times radical -1. What does this turn into? 3 plus 3i. Oh, that plus, times. Tell me what that is. Blaze.
3i squared.
3i squared. What's that? What's I squared? -1. 3 times -1 is? There's our answer. It's surprising, but the order of operations insists that we do the exponents first, which includes radicals. So if you can do the radicals first, you have to. If you're stuck, then you move on to multiplication. But these you can actually do first. Any others? Yeah.
So
21. 5 plus I over 5 minus I? Pat, just filled up with words. Yeah. I technically did anyway. It's the same technique. 5 plus I over 5 minus I. Which number is this? 21? Okay. You multiply top and bottom by 5 plus I. If you FOIL the top, you're going to get 25 plus 5i plus 5i plus I squared. You might also recognize you don't have to, but the top, if you like a little shortcut, it's actually 5 plus I parentheses squared. You can do square the first couple of products for the last. It's a binomial squared. You don't have to. And then the bottom is going to be different two squares, which is 25 minus I squared. Am I throwing anybody by going that fast? If I FOILed it, it would be 25 plus 5i minus 5i minus I squared. And then 5i and -5i would cancel. That always happens with these difference two squares things. So let's see what this is. -1, -1. This becomes +1. So it's something over 26. And then this is 25 plus 10i plus -1. So it's 24 plus 10i. The last thing to do, split this out. It's 24 over 26 plus 10 over 26i. And those reduce to 12 over 13 plus 5 over 13 i. I have time for one more for fast. If you have any. Yeah.
Can you do number 9?
Number 9. Oh, sure. 4 parentheses 3 plus 5i. Yeah. I use these for reading them. When I walk around with them, it's kind of like being in a funhouse mirror. Really good. So, okay. So, I'm sorry, which one is this again? Number 9? 4, 3 plus 5i. That really kind of tripped me out here. 3 plus 5i. That's got a little busy there. And then minus 2 parentheses 2 minus 6i. The very first thing I do is add the opposite. Add the opposite. I'm going to distribute these. So it's going to be 12 plus 20i plus negative 4 plus positive 12i. Then I put the like terms together. This will be 8 plus 32i. Any questions on that? All right. Put that away and check out your next homework, the one on solving that we did for today. Let's read off some answers. Grab your red writing utensil, your trusty companion. Let's see what we got. This is homework 1F as in Franklin. 3, 7, 9, 13, 17, 27. Bless you. Number 3. There are 2 solutions. By the way, you notice it's equal to 6. There is no 6 product property. This is what we call rude. This is them saying, here's a nice factored problem. It's equal to 6. You have to FOIL it back together, subtract 6, and then factor it again. Why? Because they're rude. It's kind of like saying, I fixed this for you, and then you say they fixed it wrongly. Then you have to undo what they did and then fix it the proper way. That's what we're talking about here. Final solutions. X equals 2, x equals negative 9 over 2. Yeah, pretty bad. Yeah.
I didn't do that. I just did what you would do with the product property, and I got the right answer.
What do you get for answers?
Negative 9 over 2. I just did 2x minus 3 equals 6, and then I just did algebra.
You did 2x minus 3 is equal to 6?
Yep. And then I added 3 equals 6, and then I did x plus 4 equals 6, and subtract.
If you had 2x plus 3 is equal to 6, that would get you,
2x equals 9, and then
that would give you positive 9 ounces. And then the other one would have been x plus 4 is equal to 6. That would have given you, that's great. That's insanely lucky, by the way. I've never seen that before. Yeah, it doesn't, always that creepy. Yeah, there is no such thing as a 6 product property. I'm actually a little, wow. I'm just, wow. I was trying to, there was one other example in my life that came close to being that creepy. It was a decimal. It's sort of like, you know, like 2 over 5 is not 2.5. Like little kids sometimes do that. They say, well, convert it to decimal, that's easy. You just grab the numbers and run. Well, you never, this is actually 5 over 2. So, like, I got a bunch of people saying, it works if you turn it upside down. No, it does not. It's insanely unlikely. Yeah, like, and then I had to come up with like 3 or 4 examples that didn't work. I still think it works sometimes. What do you say? But anyway, yes. So the way to do this is FOIL the 2, subtract 6, factor it again, then you get it. And yeah, there's really no shortcut there. Next, number 7. Z equals 34, Z equals negative 26. Number 9, X equals negative 3 plus or minus I. If you wrote them separately, it'd be negative 3 plus I, negative 3 minus I. X equals. Number 13, T equals 2 plus or minus I. That's after you reduce. Number 17, 2 solutions. Again, you gotta get the answer equals to 0. So you gotta subtract 7 and add 10x to both sides. So your final solutions are x equals 1/2, x equals -7/4. And number 27, everybody's favorite problem. T is equal to 3. Let me take a stab and guess and say people would like to see 27. All right. Now, a couple ways you can do number 27. Did I show you all what I call the machine gun method way back when? I mean, there are lots of violent metaphors I use, but so it's hard to keep them all straight. But it's dealing with fractions. Let me show you. T squared plus 1 over t plus 2. And then this is equals t over 3 plus 5 over t plus 2. The key to this is you need a common denominator. I'll be the first to admit that common denominators are annoying when you have polynomials in there. You need to include a 3, and you need to include a t plus 2. I'm going to do this the proper way the first time, then I'll show you the machine gun method. The proper way is to make sure everything has a 3, and everything has a t plus 2 on the bottom. So question. Basically, it's going to look like this. Blah, blah, blah equals blah, blah, blah plus blah, blah, blah. But it's got to have a 3 and a t plus 2. A 3 and a t plus 2. So you've got to have the pieces multiplied together. Right. Here's a quick question for you. Here's the original fraction. What's it missing? Well, I want it to look like this. What's it missing? The 3. You can do that. You can multiply by 3 as long as you do it to both sides. Multiply the top by it as well. So I'm going to do 3t squared plus 3. You might be asking, should I distribute the bottom? I wouldn't. For a creepy reason I'll tell you in about 5 minutes. Right now, the top you can distribute, the bottom I wouldn't. You won't kill anything if you distribute the bottom, but it'll make you more work. This one. Let me see. Courtney, what are we missing here? T plus 2. You can multiply by t plus 2 as long as you do it too. Yeah. Can you do the top for me? Plus 2 t. Okay. What's this missing? Sim. A 3. Multiply by 3, multiply by 3. So what are we left with? Exactly. Now, that's how you do it properly. I'm about to pull out a machine gun. We're not doing a lockdown. I just said that on video, didn't I?
Hey, YouTube.
Sorry. Randy, you do not have to call 911 after viewing this video.
YouTubers didn't.
Hey. But here is what I affectionately call the machine gun method. You notice all the denominators are 3 parentheses t plus 2. Normally I would combine these and then blah, 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 blah. Watch this. Can somebody tell me what this bar means? Just basically, it means what? It means division. They're dividing by 3 parentheses t plus 2. How do you cancel a division? Go. That is division. How do you, like if they divided by 5, how do you cancel that out? Like if you had a problem like this, x over 5 is equal to 6. How do you cancel the division by 5? Right, you multiply by 5 on both sides. Watch this. I'm loading bullets into the chamber. They divided everything by 3 parentheses t plus 2. I want to cancel them all out. As long as I do it to both sides, it's legal. I'm going to multiply by 3t plus 2, 3 parentheses t plus 2, 3 parentheses, wow, 3 parentheses t plus 2, and watch what I'm about to do. Maybe it's a semi-automatic. It's probably not a machine gun. So it goes cancel, cancel, cancel. 3t squared plus 3 equals t squared plus 2t plus 15. No more fractions. It's a site of a massacre, but there are no more fractions. Now, I need the answer down to 0. It's a quadratic. If I can't solve with algebra, 2 species of t, there are 2 species of t, I never know. Okay, there's Darjeeling and then there's Earl Grey. Okay. All the years of teaching that, I never thought of that as function, but I'll use that next year. I'm going to subtract t squared, subtract 2t, and subtract 15. So subtract 1t squared, subtract 2t, and subtract 15. I'm going to get this. It's going to be 2t squared minus 2t minus 12 is equal to 0. You tell me. How do you how do you solve?
I think you factor.
You factor. Hey, my brain does that. Is there a, what do you do factoring first? What method? Get it. GCF, is there one? A 2. What's left behind? Correct. Question. Spencer, does that factor?
Yeah.
It does. What method? You have to teach me how to do that, by the way.
This?
Yeah. But
Would it be on?
it would be on FOIL, correct. What two numbers add up to -1 and multiply to -6?
Oh, 5. 5. Negative 5 negative.
That would add up to 4 though.
Oh. 5.
Every night? You're close, go. Yeah, t minus 3, t plus 2. Back up. Can somebody solve this for me? Evan, how do you do this? Something times something equals 0. You could, although it's actually better if you don't. So if something times something times something equals 0, there's a property that comes galloping to your rescue. Zero product property. What is that? How do you do it? Zero product property is if A times B is equal to 0, then what must be true? If you multiply two numbers and get 0, what must be true about them? The 2 is actually by itself. So either 2 equals 0, or t minus 3 equals 0, or t plus 2 equals 0. And I'll tell you right now, one of these is going to be a dud. You know which one? One of these is impossible. The first, yeah. There's no way 2 is equal to 0, so you just ignore it. Josh, take over. Solve. Go ahead. T equals 3, and t equals, got it. There you go. Does that make sense? There's only one catch. How many answers did I read off when I read off the answers? Oh dear. 1. Which one? I read off t equals 3. What's up with this? Why not? He asked with a suspicious glance at the original problem. What's wrong with using t equals -2? Go.
Because in the first fraction it makes 0.
It's going to blow up. Look at the original problem. -2 plus 2 and, oh, this is interesting. Wow, okay. That's the first time I ever did that. Okay, for those of you watching at home, hi Randy. In my dramatic explosion, I flung my marker about at least 15 feet that way and almost hit the Holy Family. So, winner there. This is what we call a restriction. Okay, take a look up here. As a general rule, whenever you start a problem, if you see something in the basement that could possibly equal 0, I would say there's a restriction. I immediately tell myself t cannot equal -2. I forbid it, because I don't want people to die. And I don't want the whole family locked by a dry restart. So, as soon as I got that, I knew I had to throw it away. So the only surviving solution is t equals 3. That was a perversely fun problem. So again. Questions? Yeah.
7.
Number 7. Let me see. Oh my word. All right, you can do it. Let me. Does everybody have this down? Everybody okay on this? Oh, this is the secret. I just keep it down with my nose. Okay, 2z squared minus 16z. Equals 0. That was nice. All right, look up here, please. This is problem number 7. Let me talk you through this. What would you do first? There are several methods. Okay. What method would you use? What method did you use? Because it's not unheard of that I would put a question like this on the test. Josh, put it there. GCF of what? Sorry? Where's the GCF? 2. What's left behind? Uh, 8z minus, wow, I apologize. What's half of 1768? Anybody? Well, I'll show you a trick. What's half of 1,000? 500, somebody remember that. What's half of 700? 350. Put those together so far. 850, good. Half of 60? 3. So what is it so far? 880, half of that? 884. Yeah. Okay. We're supposed to complete the square. All right. I was getting so excited there too. All right, we can sort of get this. Good job with the 884 though. Okay, ladies and gentlemen. Settle. Take a deep breath. Got a good 15 minutes. Yeah, we got to polish off this and a little bit of new notes. Now, what is step 1 in completing the square? Go. That's actually step 2. Step 1 they already did. Yeah. Step 1 is set it equal to 0. You already did. Congratulations. Question.
Oh, I was just gonna say step.
Okay, step 2 is what?
You add 17 over here.
Yeah, cancel the C, like you were saying, and leave a space, leave a blank. Here's what step 2 should look like. Shh, by the way, sorry, Chris. Fix it better. 2z squared minus 16z plus blank equals 1760. Okay? What's step 3? Okay. Yeah, sorry about the tower. Yes, undistribute the A. So 2 parentheses what? Okay. Plus blank equals 1768. Good, thank you. Megan, take over. What's step 4? True. Although we're going to think of a suitcase. We're going to fold this into a binomial squared. Where did it come from? Like, where did z squared come from? Z, definitely. Where did this come from? Nice. How do you get minus 4? Right. This is the double product. So you undouble it. You cut it in half. So take over Mary. What number should this have been? If I do square the first double product, square the last. 16. Positive or negative? Positive. Excellent. Everybody look up here. There's some extra weight on the left-hand side. How do you make up for it?
You add 32.
Yeah, why 32? Why not 16?
Because you took the 2 out, so you have to multiply it.
Correct. It looks like we're going to add 16, but it's actually twice as big as we thought it was. So we're adding 32. Go ahead and add those. What do you get? It's actually a nice round number.
1800.
1800, very good. Everybody right so far? Katie, take over. What's the next step? Are we trying to solve this or graph it? Solve. I mean, just trying to get z by itself. What method?
Divide by 2.
Yes, what method is that? There are 4 methods for solving quadratics. Anybody? Algebra. When is the only time you can solve with algebra? Go. When there's one species of x, or z, or whatever. So, okay, Katie, take over. You were right. So divide by 2, you said? As long as you do it to do it. I'm going to put it up here. So z minus 4 parentheses squared equals what? 900. Spencer, take over.
Square root of stuff.
Square root. How many answers?
2.
2. Guess what the biggest cause of point loss is on this chapter test? People forgetting plus minus. When you square root. Keep going. Spencer, where'd you get it?
Z minus 4 equals 30.
Or
Negative.
plus or minus 30. Correct. One more step. Will, take over.
So you add.
Add 4. Where should I add it? Should I add it back here?
Yeah, you can add.
There's something wrong with writing it like that. It's not wrong, but people are going to think plus or minus 30 plus 4.
Oh.
So you might be thinking plus or minus 34, which would be wrong.
Yeah, so you can just put it in front.
Yeah, I would butt in line and put the 4 in front. So it's z equals, how would you write that?
So.
4 plus or minus. Give me the 2 answers.
So z equals 34.
34.
Then z equals -26.
Got it. There you go. Questions? All right, there was it. Any others? Yeah, Sam. 17. This is one where you have to get it equal to 0. Now, actually, Sam, can you read it off for me? It's save time.
8x squared
Was
equals 7 minus 10.
7 minus 10x? Okay. You tell me. Mary Claire, take over. What do you do first? Sorry? Get it equal to 0. How? Okay, subtract 7. And what else? Right, add 10x. I'm going to put these in order. 8x squared plus 10x plus negative 7 equals 0. Now it's kind of up to you. Somebody tell me what method. Did they specify a method on this one? It's just whichever method you like. What method do you want?
Magic.
You want magic pair?
Yeah.
Okay. That works.
That's what I get.
By the way, there's a potential disadvantage with magic pair. Magic pair is powerful. It will factor any factorable trinomial quadratic. The only thing it's helpless against is if the thing is prime. quadratic formula will solve absolutely everything, whether it's prime or not. So will complete the square, although not as many people like that for some reason. There was a year where everybody was addicted to complete the square, and I cannot explain that psychologically to save my life. It's not my favorite method because it takes a while. There are people who just say, does complete the square work all the time? And I said, yes. And they said, they must have spent the night and just welded it into their brain, which, wow. I mean, I said, but the quadratic, I hadn't even taught them the quadratic formula yet. And they said, but the quadratic, we got the quadratic formula, and great. And I showed them the quadratic formula actually comes from complete the square. And they said, oh, that's nice. Complete the square is great. But it teaches around. But this one, I will tell you, it actually does work. So go for it.
Okay, so, you multiply.
Go for it.
Oh, negative 56x squared.
Negative 56x squared. Is there a pair that adds up to 10x?
Probably.
Okay. Like what?
So, negative 56x squared, or times 1.
I give it, this is like 8 times 7.
Yeah.
And then a couple others. I would list them off. So I would do 1x times negative 56x. 2x, I'll just speed this up. Negative 28x. 3 doesn't work. 4 times negative 14x.
Yeah.
Almost.
Oh.
What would be wrong with this one?
Oh, it would be negative.
It'd be negative 10x, but you can hyperwarp
Yeah.
down to negative 4x times 14x. That's your magic pair.
So then you just add it.
Correct. I'm going to put that down here. So we've got 8x squared plus negative 4x plus 14x plus negative 7.
And then you just
Group it. Stay with me, y'all. I'm going to factor this kind of turbo.
Okay, so
the little mini GCF is 4x. And it's going to be 2x plus negative 1. This will be a 7. 2x plus negative 1. Is this going to work?
Yeah.
Yes, it will. Pull this out front. So basically 2x minus 1 times 4x plus 7 equals 0. And now do zero product property. 2x minus 1 equals 0. 4x plus 7 equals 0. And when you get all done, you can have x equals positive 1/2 and x equals negative 7/4. And you could do the quadratic formula, it'll do the exact same thing. Maybe a little faster. I'm not sure. Pretty good? All right. I want to give you, take out your notes, please. There's not a heck of a lot of time left, but I want you to at least start. And for those of you who have lawyer-esque minds, you probably deduced that yes, there probably is no homework over the weekend. Don't get used to it. Few things. Go ahead and write this down. A standard, especially if you've never heard this before, a basic parabola pattern. You start at the vertex. Can somebody know what a vertex means? What's a vertex of a parabola? Like, for example, a parabola is a kind of U-shaped thing that you get with squares and things like that. Where's the vertex? Yeah.
It's at its lowest point.
Right, it's right here. This is the vertex. And if you happen to have an upside down parabola, same difference as at the top. The vertex is the extreme point, the starting point. So you start at the vertex, and for a normal basic parabola, you go over 1, up 1. Then start over at the vertex. Over 2, and remember, up what? Yeah, 4. Over 3, up 9. Over 4, up 16. Over 10, up 100. Over n, up, that's a letter, n squared. That's the pattern. So over 1, up 1, start over. Over 2, up 4, start over. Over 3, up 9. So it looks like this. A normal parabola, if you don't move it anywhere, starts at 0, 0. So what happens is you go over 1 both ways and up 1. That'll give you your first pair of points. Start over. Over 2, up 4. It is important to keep starting over. That's actually good now. Do a curve. And there's your basic parabola. It's like y equals x squared. Please do not keep going. I've seen some people do this. Over 1, up 1, and start from there and go over 2, up 4. And from there over 3, up 9. You're going to get a parabola with lumps. It's going to be a lump, 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 which is awkward. It's not a parabola, it's just a lumpy mutant, something like that. So make sure you always start from the starting point. Okay? Tomorrow, not tomorrow, Monday, we're going to be talking about all the different ways to play with this. There are basically 3 ways to change a parabola. You can move them, you can resize them, and you can flip them. And we're going to show you how to do all 3 on Monday. And that is all I have for you. Ready? Good enough? That's a marker to say my life. So for those of you listening at home, Irene, God bless you, whatever you're doing there. And thank you, stars, that you weren't in the way of the dry erase marker. And this is my hand waving bye. Talk to you later.